Hi everyone, I'm Omale Jeff Ejojo, a celebrity mathematician. Welcome to the examples on indices. Last time we treated the rules, and I was able to give about 10 rules. 10 rules, I gave it out, and I still gave two conditions. I said, maybe you must have forgotten, I said that a plus b raised to the power of y is not equal to a raised to the power of y plus b raised to the power of y. E.g., 2 plus 3 raised to the power of, let's say, 2 is not equal to 2 raised to the power of 3 plus 3 raised to the power of, 2 raised to the power of 2 plus 3 raised to the power of 2 is not equal to 2 plus 3 is 5. 5 raised to the power of 2 is not equal to 4 plus 9. 3 raised to the power of 2 is 9. 2 raised to the power of 2 is 4. 5 raised to the power of 2 is 5 times 5, which is not equal to 4 plus 9. 25 is not equal to 13. You get? So I gave a section on this last time, and I said let me do the example to clear you. In the same way, I said that a minus b all raised to the power of, let me say x on this one, is not equal to a raised to the power of x minus b raised to the power of x. That is, a, let me give an example, 2 minus 3 raised to the power of 2 is not equal to 2 raised to the power of 2 minus 3 raised to the power of 2. That is, 2 minus 3 is minus 1. Minus 1 raised to the power of 2 is not equal to 4 minus 9. Minus 1 raised to the power of 2 is minus 1 times minus 1. I'll put it like this. Is not equal to 4 minus 9. Minus 1 times minus 1 is 1. Minus times minus is plus. Is not equal to minus 5. So those are the two conditions. But there's another law. Let me just add to it. Just put it. If you reach there, make sure you put it. If I have a, let me say a raised to the power of x is equal to a raised to the power of y. It implies that, it implies that x is equal to y, provided a is not equal to 1 or 0. Now we have the base here is the same with the base at the right hand side. Then their power, the indices, will now be equal to at the both sides. For example, a raised to the power of x is equal to a raised to the power of 2. Implies that x is equal to 2. Then if you have 3 raised to the power of y equal to 3 raised to the power of 4, you come across, after solving mathematics or anything, you come across something like this. When they're having the same base, equate the power. This implies that y is equal to 4. Simple. So this is 11th, the 11th rule. Please take note of it. And the first one, let me start from the first. I said the example. I said that a raised to the power of x multiplied by a raised to the power of y is equal to a raised to the power of x plus y. For example, if I have 2 raised to the power of 3 times 2 raised to the power of 4, it's the same thing as saying what? 2 raised to the power of 3 plus 4. which is the same thing as 2 raised to the power of 12. 7, I mean to say. Because 3 plus 4 is 7. So, and 2 raised to the power of 7, we say that the 7 is what? The 7 is index or power or exponent, and the 2 is the base. This index, which is 7, is telling us the number of times that 2 multiplied itself. In that case, I have 2 times 2 times 2 times 2 up to 7. So do that and get your answer. Same thing as what? 2 times 2 times 2 times 2, 1, 2, 3, 4, times 2 times 2, 1, 2, 3, 4, 5, 6, times 2. That is 2 into 7 places. So the second law, I said a raised to the power of x divided by a raised to the power of y, the same thing as a raised to the power of x minus y. For example, if I have 2 raised to the power of 3 divided by 2 raised to the power of 2, this is the same thing as what? 2 raised to the power of 3 minus 2, which is 2 raised to the power of 1. 3 minus 2 is 1. And 2 raised to the power of 1 is 2. And 2 raised to the power of 1 is that the same thing? Because this one, the index here is 1. And it's telling us that 2 just multiply itself one time, which is 2. So, we have the third one. We say that a raised to the power of 0, we say is equal to 1. That means 4 raised to the power of 0 is 1. There's a proof for this, but it's beyond your scope. In the same vein, 1 billion raised to the power of 0 is 1. So anything raised to the power of 0 is 1. That's what I'm here to tell you. We are still doing other bigger examples, so but just take this basic. When I say that the third one, we said negative power law. I said that a raised to the power of x is the same thing as 1 over a raised to the power of x. For example, 2 raised to the power of minus 3 is the same thing as 1 over 2 raised to the power of 3, which is 1 over 2 times 2 times 2, which is 1 over 8. Now, do you know what this thing means? In case you have a negative number in this way, the only way you can remove this minus is to put it like this. Indices makes this possible for us. So that is the fourth one. Take note of all these things, because if you enter into the mathematics, even if it's higher in anywhere you reach in life, you must apply these rules. And when you are conversant with these rules, or when you understand these rules, mathematics will be simple for you. Even if you are doing fractions and others, laws, all these laws will be coming. There's a place you solve mathematics rules that you come to this, and you'll be surprised. So take note of this very well. We have done justice to that very one as well, and that is the fourth one. I've done justice to that last one, for example. Then the fifth one, I said let me say a raised to the power of x over y. And I said that this thing is the same thing as the denominator. Take note of this. The denominator will serve as the root, and the numerator will serve as the power. Let me write it in a bigger way so that you can see it. If I have a raised to the power of x over y, you can see it clearly here. This is the same thing as what? The white root of a. raised to the power of what? X. This is what I mean. Now, for example, if I have 4 raised to the power of 3 over 2, and I have it in this form, this is what? The square root of 4 raised to the power of 3. Now listen, I not write 2 here because 2 itself is the root, so you don't put 2. So this is the same thing as what? The square root of 4 is 2 raised to the power of 3, which is what? 2 times 2 times 2, which is 8. There's one thing I want to explain here. This root can be what? 1 over 2. Let me do it in another way around. Or the square root of 4 raised to the power of 3 is the same thing as what? 4 raised to the power of 1 over 2 raised to the power of 3, which will bring us to this place. But I'm not going there, because when the 2 power multiplied, I have 3 over 2. Look at it. I can say that is 2 raised to the power of 2 raised to the power of half. Then I have the first one they gave to me, which is 3. I'm breaking down this, that instead of me writing the root, this root is 1 over 2. If I have cube root, it's 1 over 3. If I have fourth root, it's 1 over 4. So this one now, 2 times 1 over 2 is 2 over 2, which will give me 2 raised to the power of 2 over 2 raised to the power of 3. 2 over 2 is 1, which will give me 2 raised to the power of 1 raised to the power of 3. And 2 raised to the power of 1 is 2, which is 2 raised to the power of 3. And this will give me 8. So, for example, if I have if I have this thing in this way, I want to show you something so you can understand. In case you see something big, what you should do, you do justice to it immediately. If I have cube root of 8, cube root of 8, this thing is the same thing as what? 8 raised to the power of 1 over 3. The cube root, instead of me to, I'll decide to write it in this form so that I can use indices for me not to disturb myself. And 2 raised to the power of 3, 2 times 2 is 4, 4 times 2 is 8. So I can have something like this, that 2 raised to the power of 3, it will give me 8. So 1 over 3, which is this cube root. This will give me, in power law, that's why I told you in mathematics, you must be seeing all these rules. Power can multiply itself. And this will give me 2 raised to the power of 3 over 3. 3 times 1 over 3. Which will give me 2 raised to the power of 1. And 2 raised to the power of 1 is what? 2. So the cube root of 8 is 2. So this is why mathematics is sweet. And the one I'm going to, which is power law, is what I've been explaining here. If I say that is the 6th one, power law. If I have a raised to the power of, some people will say I'm using xy. Let me use mn. A raised to the power of m raised to the power of n is the same thing as a raised to the power of m times n, which is the same thing as a raised to the power of mn. I told you, in mathematics, when there's no sign between them and they're writing, then that means it's multiplication. I showed you it here, then I left it in this form. For example, if I'm having 4 raised to the power of 4 raised to the power of 2 raised to the power of 3. This is the same thing as 4 raised to the power of what? Let me remove the symbol. 2 times 3, because it's parallel, which is the same thing as what? 4 raised to the power of what? 6. And this is the same thing as 4 times 4 times 4 times 4 times 4. 1, 2, 3, 4, 5 times 4. You get? Because this 6 is telling us that this 4 is multiplied by itself 6 times. And that is the index. So you do this calculation yourself and bring the answer out. So that is all about the power. What I'm trying to show you is that the 2 times 3 will multiply itself. Once you come to power, even if you are doing logarithm and you come across this is what happened. I gave another one, which I said the 7th. If I have a raised to the power of minus x over y, the same thing as 1 over a raised to the power of x over y, which is the same thing as what? 1 over y root of a raised to the power of x. The denominator will serve as a root, the numerator will serve as a power. For example, if I'm having 27 raised to the power of 2 over 3. This is the same thing as what? 1 over 27 raised to the power of 2 over 3. And this is the same thing as what? 1 over the cube root of 27 raised to the power of 2. Now 27, if I have 27 in this form, I thought that the cube root is the same thing as what? 1 over 3. Because that will make you to do it faster than start looking for what to use. Try to break it down. This is the same thing as what? 1 over, 3 times 3 is 9. And 9 times 3 is what? That is 9 plus 9 will give me 18. 18 plus 9. This is 17. Then 1 plus 2. 17. 1 plus 1 will give me 2. 27. Now, what I will do is for me to write what? 1 over this. Then 3 raised to the power of 3. The cube root is 1 over 3. Then raised to the power of 2. So I would have done this directly, but we want to know from the power law that the two powers can multiply itself. And if these two powers multiply itself, I have what? It will be 1 over 3 raised to the power of 3 over 3, all raised to the power of 2. I have to finish from the bracket first, board mass. 3 divided by 3 is what? 1. So I have it to be what? 1 over 3 raised to the power of 2, which is the same thing as what? 1 over 3 times 3, which is 1 over 9. So if you are doing it in this form, I know that the cube root of 27 is 3. So 3 raised to the power of 2 is 9. So I've done justice to this because the two lines I did justice to them in the last class. Now what we are going to do is how to appreciate indices in the next class. How do I appreciate indices? You are going to see different things that will do that if you start doing logarithm, you will enjoy it. And for some of my children in primary school, during this break, we are going to do some calculations. So tell them to come to Matex. They can download it on YouTube and they can watch it on Facebook. Thank you so much. I remain Omalaje Jojo, your celebrity mathematician.